Okay, now we're ready to look at locational elements. Locational elements. Now, locational elements are going to be your shoulders, retaining rings, things that keep stuff in place on your shaft as this is going to be rotating and keeps it located. So I'm going to go back to our module 7, and we're gonna look at our learning plan or overview. And down here in session number 4, here is our locational elements section. Now, I do not have a spreadsheet for this because this becomes just sizing based on other elements that you've already designed. Most specifically for retaining ring, it's going to be the diameter of the shaft. Okay. Then we're also going to be looking at your radii and your shoulders, and those radii are going to be dictated by the ratios that are called out in chapter 12 when we did our KT factors. So we're going to be revisiting that. So there is no spreadsheet to do any calculations here. We're going to be incorporating this into the design. So, so let's look first at the retaining ring catalog. Okay, the retaining ring catalog. Now, this is a PDF. I did print my PDF out. I'm going to put it underneath our camera here, but I'm going to show you how you, whoopsie, wrong way, how you would use this to size. Now, this particular vendor, I think it's called Rotoclip, www.rotoclip.com. So if you wanted to go to their website and, you know, see their large array of products and their catalog selection, you're welcome to do that. But I kind of pulled out some catalog pages here. Now, there are different types of retaining rings, and the type of retaining ring that we would be using is called an external retaining ring or shaft rings. Okay. And what it's going to do is, you can see here, this is a cutaway. We're going to put a groove, as we know, on our shaft. And that shaft then is going to accommodate this retaining ring. So the diameter is going to be down in the diameter of the groove, but then it's going to stick up above. And for like the element that is hatched here, this would be, for instance, our gear. Our gear would be mounted up against a shoulder on one side and a retaining ring on the other. And all that this retaining ring does is it creates kind of this, this little shoulder on the other side that we can remove, that it doesn't allow that gear to walk off the shaft. Now, in theory, if things were lined up perfectly, it shouldn't, right? But in actuality, things aren't going to be lined up perfectly. And over time, things are going to want to walk away, right? So to ensure that that gear doesn't walk away, we're going to put that retaining ring there. Okay. So it's not like it's like, you know, using force to hold it in. It's just really kind of something for that gear to bump up against and then kind of stay where it's supposed to. So we need to accommodate for that. Now, that is going to be based on your shaft diameter. So if we go down here, you're going to notice our very first column here is shaft diameter. And once you find your shaft diameter here, the nominal shaft diameter, you're going to go over to the right and you have a column for the groove size. So there's going to be the diameter and the width. And then additionally, for the different sections, it's going to give you tolerances that you have to apply. Okay, for both the diameter and the width. Okay, so you pick your retaining ring based on the nominal shaft diameter that you chose for that area, but then our manufacturer tells us what our dimensions are. Okay, so this is another example where we don't have to pick the fits. We don't have to determine what it is. We're going to use what they're suggesting so that it fits in, and it's going to do what it's supposed to do. Now, as we go down here, you're going to notice that these tolerances change. So you have to know where you're at in the chart, but the diameter and the width and what their tolerances are what you're going to be interested in. It's really that simple. Okay. We did not do a module in our book on retaining rings. I mean, a little bit of, you know, calling them out KT factor wise, but sizing wise, it's exactly that. Okay. So if we look to our assignment, oopsie. If we look to our assignment, and I'm going to go back to the module and go to our gearbox locational elements, you're going to notice that you're going to create a spreadsheet. Now, it's not to do any calculations. It's just to create a list of the items that you're going to be purchasing. So anytime you have a retaining ring, you potentially could have 1, 2, 3, 4, I guess 4 retaining rings, right? You could have 4 retaining rings. If you have a shoulder on one side, retaining ring on the other, then what you want to do is you want to create a list. Okay, here's my first one. Here's the vendor. Here's the part number. And I want to make sure that we know what the groove diameter limits are. So not just the nominal value. I want to know, what does it say? +2, -0, and then what that high value is, what that low value is. Okay, so limits. Same thing with the groove width. I want to know what those limits are that you collected from a vendor. Now, if you don't want to use Rotoclip, you don't have to. If you want to use another vendor, that's totally fine too. I don't mind, but you're still going to have to gather from them what they're telling you those limits should be on the diameter and the groove width. Okay, so that's retaining ring. Any questions on that? Okay, so anywhere that you had a KT of 3, now you're designing in that actual retaining ring. The other locational element that we have to keep in mind are radii and shoulders, radii and shoulders. So this comes out of chapter 12, So let's go underneath. And what I'm referring to is on page 517, this was where our KT factors were. And this probably looks familiar in the first column at the bottom. When we were deciding like where to put our bearings or where to put our gears, we knew that when we would locate up against a shoulder, if it was a gear, we had control over that radius and we identified it as a well-rounded radius. If it was a bearing, we knew that it was going to be tiny, so then it was going to create a large stress concentration factor. But you know, our bearing then is going to dictate what our diameter has to, or our radius has to be for that. But now what we want to do for our well-rounded radiuses, okay, we want to make sure that our radiuses are appropriately sized so that they meet the specification or the KT factor that we identified as 1.5. Okay, as 1.5. Now, to do so, you're going to notice that, and they did this conveniently, but I think it adds a little bit of confusion. Okay, so this is the shaft that we're going to be mounting an element on. In our case, it's going to be a gear. Okay, and we know that our gear is going to go up against this shoulder right here. So our gear is going to sit right here. Now, our gear is going to have a bore on it. Right? Our gear is going to have a bore. So the bore is going to go through here. It's going to fit on our shaft diameter, but we need to do a lead-in. We need to put a chamfer on the front end of that gear. And that's what you see here. So this is the bore of the gear and this is a chamfer. And what that chamfer does is we want to have that chamfer large enough so that when it comes in contact with the shoulder, that it is not stopping on the radius. So we can't have our radius too big, okay? And we have to then think about, we have to make our chamfer large enough to go over the top of it, but then also is going to also come in contact with the shoulder as well. So what I want you to think about, and what I want you to determine is, what is my radius size here? And then what is the chamfer that's going to go over the top? Those are the two things that you're going to be specifying for each one of your gears on the shoulder side, okay? So as we look here, you're going to notice that they give us some ratios. So our ratio is going to be small r over small d is equal to 0.19. So I'm going to say r over d is equal to 0.19. So the small d, the lowercase d, is the diameter of the shaft, okay? And the radius, the small r, is going to be the radius in the corner. Now, they happen to pick a diameter of 1 inch. So what sometimes happens is students think, oh, I just have to put a radius of 0.19 and that's going to be large enough for me to use a KT factor of 1.5. No, no. It is a ratio of your radius to your shaft diameter. Okay, so if your shaft diameter is anything other than 1, your radius is going to be different. So we can rearrange this to say r is equal to 0.19 times your diameter. That's going to be how you determine your radius. So whatever your diameter is, you multiply it by 0.19, and this has to be the minimum size radius. If you go larger, that's okay. All right, larger better, but this is the minimum radius to call out a KT factor of 1.5. Does that make sense to everybody? So theirs came out to 0.19 because their diameter was 1. 1 times 1.9, that radius is 0.19. If your radius is or your diameter is something else, you're going to multiply it by 0.19, and that's going to be your minimum radius. Now, if your minimum radius comes out to be 0.12867, you want to round it up to the next nominal value. So for instance, if it's 0.128, you're not going to round it down to 1/8 of an inch. You're not going to put it down to 0.125. You're going to go up probably to maybe 3/16 of an inch. So you want that radius to be I like to say, a nice number, a number that somebody's going to be like, all right, you know what you're doing. If designs work on goofy numbers, but people who are making your stuff are going to want nice numbers. They're going to want to have things to nominal sizes. Okay. So think about that as you're designing this. Okay. So this is going to be your minimum, and then you want to make it a little bit larger to bump it up to a nominal inch increment. And it can be to the 16th of an inch, the 32nd of an inch. That's okay. That's okay. But don't go on like weird numbers that aren't a fractional equivalent. Okay. So if we look back at the assignment here as well, we're not designing, there's not a spreadsheet to design this. This is kind of like I got to figure it out. So on this deliverables, on this locational elements spreadsheet that's just going to list your findings, you're going to add a radius size on the shaft. Okay. And then what is the chamfer size? Oh, I got to talk about that. The chamfer size on our gear. The chamfer size on the gear becomes actually pretty simple. If we go back underneath at that same place, that chamfer just has to be large enough to go over the top. So once you figure out your radius, you just want to make it like a 32nd bigger, the chamfer, and that's it. So then that's going to be a chamfer that's a little larger to accommodate, because we don't want to stop on the radius. We want to make sure that we're coming in contact with the actual shoulder. Yes.
What those, like, because if you buy the gears, they're not gonna be on already.
Nope. We're going to buy our gears. We're going to bore them out. We're going to broach them, and we're going to add a chamfer to the front. We're finishing them off. We're buying gear blanks. We're making sure that we can bore them out large enough, but we're going to do the finish work. And again, most often we would be taking that next step further, where we would be making the drawing, but we just aren't in this class. We're just specifying, and we're getting right before we're going to make that drawing or that model. Now, if you wanted to model this up to check it out, go right ahead. Not required though. Okay, not required. I'm not going to do that for that because that's dictated by, again, the manufacturer. Other questions? Okay. All right. So those requirements here are, again, just a list on a spreadsheet. You know, if you wanted to create a list on a Word document, I'm okay with that too. If you didn't want to use Excel for that, it's just, we've been using Excel for so many other things. It's kind of nice to be able to add it in as maybe a tab. And these would just be your findings for your locational elements. So the items that are listed here. Okay. So any questions overview wise? Okay. Now I'm going to go to our module list here. And I know you haven't gotten access to this just yet, but it will be out here shortly. So after locational elements, we've gone through all of these things on top, okay? And the only last two things that are here that you don't have access to yet are the final assembly and the project portfolio. We will be talking, I'm sorry, final layout, not assembly, final layout and the project portfolio. We'll be talking about those in our last session, which is going to be next time when we meet. Okay. So, so then that really, after locational elements, There really isn't any more design work to do. Okay, that's really it. So, so if you're wondering like when this is coming to an end, we're kind of there. And then it's buttoning it up with those last two elements, okay? So, so we'll get to look forward to that for the next time we meet, but otherwise keep working in the, in the middle here. And, I'm available to answer any questions that you might have.